Welcome back, team. Today, we are tackling a major challenge in generative AI, processing real-world documents. We will master multi-vector retrieval, focusing specifically on how to seamlessly handle tables, images, and text in your RAG pipelines. Let's get started. Let us begin by defining the problem. If you take a standard text splitter and run it over a PDF containing a financial table, it will read straight across the columns, turning structured data into complete gibberish. The same applies to images. You cannot natively embed a JPEG into a standard text vector store. Multi-vector retrieval solves this fundamentally. The core concept is decoupling what we search from what we retrieve. Instead of indexing the raw table or image, we use an LLM to generate a clean, searchable text summary of that media. We index this summary for search, but when a match is found, we retrieve the original, rich format, the intact table, or the raw image and pass that to our model for synthesis. Looking at this flowchart, you can see the ingestion pipeline for mixed media. Our mixed document splits into text, tables, and images. The text can go straight to the vector store. However, the tables and images take a detour. They are processed to generate text summaries and captions. These descriptive texts are what ultimately enter our vector store, ensuring all our mixed media is cleanly represented in a semantic, searchable format. How do we architect this decoupling? Multi-vector retrieval relies on a dual storage system. On one side, we have our vector store. This is optimized for fast, semantic similarity searches and holds the dense embeddings of our text chunks, table summaries, and image captions. On the other side, we have our document store, often implemented as an in-memory byte store. This holds the heavy, raw assets, the full markdown tables, and the base 64 encoded images. The bridge between these two worlds is a unique identifier, or UUID. When we ingest a table, we give its summary and its raw data the exact same UUID. During retrieval, the system finds the summary in the vector store, grabs the UUID, and instantly pulls the raw asset from the document store. This architecture diagram illustrates the retrieval execution. A search query enters the system and queries the vector store on the left. The semantic search matches a summary and extracts its UUID, let's say, 123. This ID flows through the router directly into the document store on the right. The document store locates the raw asset associated with ID 123 and returns the intact table or image directly to the LLM for processing. Let us take a deep dive into handling tables. The first critical step is extraction. You must use specialized parsing libraries, like unstructured.io, to extract tables while preserving their underlying schema, typically as HTML or Markdown. Once extracted, we perform a map step. We pass the raw table to an LLM and prompt it to generate a summary, such as Q3 2024 revenue breakdown by European region. We embed this short, highly semantic summary into our vector store. Simultaneously, we save the raw HTML table into our document store. When a user queries European revenue, the vector store matches our summary. But the beauty is, the LLM receives the full HTML table, meaning it can accurately read rows and columns to answer complex analytical questions. Follow the sequence diagram to see the ingestion of a table. The parser extracts the table and sends the raw HTML to the LLM. The LLM generates and returns a table summary. The ingestion script then splits the data. The summary and UUID are sent to the VectorDB for indexing, while the raw HTML table and the exact same UUID are sent to the doc store for safekeeping. Handling images requires a similar, yet multimodal approach. We utilize vision models, such as GPT-4o or Gemini, to act as our eyes during the ingestion phase. We pass the raw image to the model and prompt it to generate a highly detailed caption. If it is a graph, we ask it to describe the axes and trends. This textual caption is then embedded and loaded into our vector store, making the visual content searchable via text. The original image is base 64 encoded and placed securely in the document store. When a user's question triggers the caption in the vector store, the system fetches the base 64 image. Crucially, your final generation step must use a multimodal LLM so it can actually see the retrieved image and synthesize a perfectly grounded response. This flowchart maps out the image processing workflow. The raw image is base 64 encoded and fed to the multimodal LLM. The LLM generates a rich image caption, which flows directly into the vector store for indexing. Concurrently, the base 64 data of the image bypasses the LLM and goes straight into the document store. The dotted line represents the UUID link that binds the text caption to the visual data. Let us look at how we implement this in LangChain using the multi-vector retriever class. The setup requires initializing your standard vector store, an in-memory byte store for the raw assets, and defining an ID key, typically named docID. During ingestion, you iterate through your summaries and generate a unique UUID for each. You create a document object for the summary, embedding this UUID directly into its metadata, and push it to the vector store. Then, you bind the raw HTML table or base64 image to that exact same UUID and save it to the byte store using the .set method, passing a zipped list of IDs and raw content. The multi-vector retriever automatically handles the complex mapping during runtime, seamlessly swapping the matched summary for the raw document. Here we see the class structure for multi-vector retriever. It acts as an orchestrator, maintaining properties for the vector store, the byte store, and the ID key. The invoke method handles the user query. Below, the standard document class shows how the page content holds the summary, while the metadata dictionary holds the vital UUID, linking back to the retriever's logic. Let us solidify this with a highly critical real-time use case, a financial report analyzer processing enterprise 10K filings. These documents are notorious for dense text interspersed with complex profit and loss tables and revenue charts. If you use standard RAG, the text splitter will fracture the tables and completely ignore the images, guaranteeing hallucinated financial advice. By implementing multi-vector retrieval, we generate highly semantic summaries of every table and graph. When a financial analyst asks, "What caused the dip in Q3 margins?" the system matches the text summary of a specific revenue chart. It instantly pulls the actual image of the chart and the raw HTML data table from the document store, feeding both to a multimodal LLM. The AI can now synthesize an answer using visual data and tabular metrics simultaneously, ensuring enterprise-grade accuracy. This flowchart maps the real-time execution of our financial analyzer. The analyst's query hits the multi-vector retriever, which perfectly matches a semantic summary. This match triggers parallel fetching, grabbing the HTML table and the chart image from the document store. Both raw assets funnel directly into our multimodal LLM, which processes the rich context to deliver a highly accurate financial analysis on the right. As we prepare to deploy, we must be senior engineers and acknowledge the trade-offs. Multi-vector retrieval is incredibly powerful, but it adds architectural complexity. Generating text summaries for every single table and image requires hundreds of additional LLM calls during the ingestion phase, which noticeably increases both your pre-processing time and your API costs. Furthermore, you increase your storage overhead by maintaining two separate databases, and invoking multimodal models at runtime adds latency. However, the verdict is clear: if your business application relies on PDFs, reports, or mixed media documents, this investment is not optional. It is mandatory to prevent hallucinations. That wraps up our deep dive into multi-vector retrieval. Please be sure to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final mind map summarizes the strategic considerations. Branching from the center, we have the challenges on the top: increased API costs, storage overhead, and higher runtime latency. But look at the bottom nodes, highlighted in green: maximized accuracy and breakthrough multimodal capabilities. The benefits at the bottom far outweigh the infrastructural costs at the top when building robust AI systems. Thank you for watching.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question this is way you can answer it and you can move to the next question. Now, third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechit.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.